In this class, we will see how to find the area of bounded regions, or in other words, area of regions which are enclosed by different figures. We will start with two figures you are familiar with. One, a circle, another one, a parabola. Now you know that the area of the circle is pi a square, where a is the radius of the circle, but that is the area of the whole circle. We don't need that. We just need to find the area which is enclosed between the circle and the parabola. Now consider another example. Consider an ellipse and a line passing through it. Now we know that the area of the whole ellipse is pi AB, where A and B are the length of the semi-major and the semi-minor axis. But that is the area of the whole ellipse. We don't need that. We just need to find the area that is enclosed by the ellipse and the line. How do we find that? That is where integration steps in to help us. We can express this area as a definite integral, but that is the end of the road for us. That is what we eventually want to find out. But then we will not dive into the deep end. We will take baby steps. We will not start with two curves. We will just concentrate on one curve, and we will find the area bounded by that curve, the x-axis, and 2 points on the x-axis. That is how we will start with just one curve, and then we will move on to two curves. Let us see how that works out. Now this is going to be our first step. We are not going to start with two curves. We are just going to start with one curve. Now the curve I will take is a circle. You can take any curve you want, a parabola, an ellipse, or whatever you want. Here I am taking a circle. Let the equation be x square plus y square is equal to r square. That means it is a circle with its center at the origin and radius r. So what are we going to find? The area bounded by the curve, the x-axis, and two lines. X is equal to A and X is equal to B, or in other words, the ordinates. What are the ordinates? They are the lines passing through the x-axis and parallel to the y-axis. So I will draw the y-axis also. So here, so what is the area you are talking about? The area bounded by the curve, the x-axis, and these two lines, or in other words, you are talking about this area. Now, what is the significance of this? What is the significance of taking just the x-axis and two ordinates? That's not maths. Bible will tell you the answer for that. I think it is in the book of Matthew. No man can serve two masters. That is exactly the situation we are trying to avoid here. We don't want to be dealing with both x and y. We want to reduce it. So what have we done? We have taken x-axis. What is the equation of the x-axis? It is y is equal to 0. So what we are going to do is trying to get rid of y and make it completely in terms of just x. So I have already written down what the formula is. The formula is a to b y dx. But again, you have a y, right? You are integrating with respect to x. The limits are that of x, but still you have a y, right? So what do we do with that y? Any point on this circle is given by the ordered pair xy, which satisfy this equation, x square plus y square is equal to r square. So from this you get your y to be plus or minus square root of r square minus x square. Remember, whenever you take a square root, for example 4, the square root of 4 will always have a plus or minus option. But here I will just take the plus option. Why is that? Because it lies in the first quadrant where x and y are always positive. So I will take the y here and I will take the y here and I will write it as this. But remember, that is what this modulus here is for. You notice this modulus, I have written y here, but here I have written modulus of y. Why is that? Because if you are taking here, if your y falls somewhere in this area, then you will have to take minus y. What will happen if you don't put the what will happen if you don't take the minus y? The sky is not going to fall down. All you will get is that your area will be a negative number. Of course, your area cannot be negative. It has to be positive, right? So that we are just trying to avoid that situation. That is just what that modulus means. So remember, depending on where your y falls, if your y falls in the positive y-axis place, take plus y. If it falls here, take minus y. Now, we have taken this curve. We have taken a circle. That is why our y ends up to be r square minus x square. But remember, if it is a parabola, y square is equal to 4ax, then your y will be square root of 4ax. So, whatever this y here, you will find the answer from the curve. But then the situation is same. The formula is same. The formula is always to find whether it is a parabola, whether it is an ellipse, whether it is a line. Always the area formula will be same. You will have to integrate from a to b y dx. So, but how do we get that formula? That itself is very interesting. We will see how we get this formula a to b y dx. I will not go into detail about that. I will just briefly explain what is the concept here. We need to find the area of this region, right? Let us divide this region into thin vertical strips. So it is a rectangular strip. This whole area, just cut it into small rectangular strips. So now look at the foot of the rectangle. Where is it? It is along the x-axis, and it is incredibly small. It's very, very, very small. A small quantity along the x-axis. So how do you denote a very small quantity along the x-axis? We denote it by dx. Now we have to find the area of just this small rectangle. So what will its length be? Any point on this this circle is denoted by the ordered pair xy, which satisfy the condition x square plus y square is equal to r square. So the length here is what? Y. But is the breadth x? X would be all the way from here. From here to here would be x. From here to here would be y. The length is y. But what is the breadth? The breadth is this incredibly small one, dx. So this is the area of just this small region. But that is not what we need. We need all the way from a to b. So integrate it from a to b. There you have your answer. So the area of this, where one foot of the rectangle is on the x-axis, the other foot is on the curve that you need, then you will integrate it from a to b. Now the same thing with a small difference, we will consider it with y-axis and two lines, y is equal to a, y is equal to b. Now the same thing we are going to do here again, but what are we going to do this time? This time we are going to ignore x and get it completely in terms of only y. So how will we do that? There you have your circle, and there you have your x-axis and y-axis, but this time remember we are taking from the y side. So this is our second condition. What are we going to do here? We are going to repeat the same thing. We have taken the same curve, x square plus y square is equal to r square, but this time we are going to find the area of the region enclosed by the curve, the y-axis, and 2 points, y is equal to a and y is equal to b. So what are we trying to do here? The same thing, but instead of getting rid of y, we are going to get rid of x this time, and it all follows the same way. Again, form a rectangle, small, thin, but there it was a vertical rectangle. Here it will be a horizontal rectangle. Its 1 foot will be on the y-axis. That means it will be denoted by an extremely small quantity dy, and any point here you can take as xy. So the area of just this strip will be x dy, but this small strip is not what we need. We want all the way from a to b. So integrate it all the way from a to b. You will get the area of this region. Again, remember, we have an x here. We cannot integrate x with respect to y. You cannot integrate x with respect to y. So you have to remove that x and take a function only in terms of y. Only then you can integrate it with respect to y with the limits of y. So you need a y function there. So that is r square minus this, plus or minus, this will be your x. Instead of x you can write this, but remember you don't need the minus here because again you are talking about the first quadrant. But if it falls to this side where x-axis, the negative side of the x-axis, remember you have to put a minus. That is why in most textbooks you will find the formula of the area is given like this. It is given as mod x. It is not something too complicated. All you have to do is adjust the value so that your area does not become negative. So that is what we do. Now we will start doing our question answers. Our whole topic is divided into 3 set of case studies. The first one will be this. We will be dealing with just one curve and the area bounded by the curve and the x or the y axis and 2 lines on that axis. We will start doing the questions. Now this is our first question. We have to find the area of an ellipse whose equation is given by x square by a square plus y square by b square is equal to 1. First let us draw the ellipse and see how it looks like. This is how your ellipse will look like. Obviously its center is at the origin and then you draw the major axis and the minor axis and all of that. This is how your ellipse will look like. Now we have to find the area of this whole ellipse. Now what can we start with? What have we learnt? What equation do we already have? We can find the area which is enclosed by what? Enclosed by a curve. You have the curve here, then the x-axis, you have the x-axis here, and then you need 2 ordinates. Now what if we just find the area of this region and then multiply it by 4, then we will get the whole of the ellipse. Why does that happen? Because ellipse, as you can see from this figure, you can see it is symmetrical along both the x-axis and the y-axis. So all you have to do is find the area of this portion, just this one portion which lies in the first quadrant, multiply it by 4, you will get the area of the whole ellipse. Even before you start, you should know what the answer is, right? What is the area of a circle? It will be, say, pi a square, where a is the radius, and for an ellipse it will just be pi ab. The area of the whole area will be pi ab. Then its quarter will be divided by 4. So this is the answer. This area, this should be your answer. This is what we are aiming for, but we will see how we come to it. So what if we concentrate on just this area? So do we have all the things we need? We need a curve, we have it. We need the x-axis, we have it. And we need 2 ordinates. Why don't we take this one? the y-axis. What is the equation of the y-axis? It is x is equal to 0. And what about this line? What is what is its equation? Its equation is x is equal to a. So there you have your 2 ordinates. See, done. Then what is the equation for the area? It is from 0 to a. And then what is y? Y, equation of y you will get from the curve. What is the curve? This is the curve. From this get the equation for y. What will it be? This will be your y. So substitute your y here. There. You have made it completely in terms of x and got rid of the y. So now integrate it. This is a constant. This comes out. Then on integrating you get This is what you get on integrating. For the upper limit, what will you have? This thing. When you put a here, this whole thing becomes 0. But when you put a here, what happens? A by a, 1, sine inverse of 1 is what? You will get sine inverse of 1 is pi by 2, right? So you will get pi by 2 here. Now, put for the lower limit, what will you do? Wherever you see an x, substitute a 0. You put 0 here, this whole term becomes 0. You put a 0 here, this whole term becomes 0. So, sine inverse of 0 is what? It is 0 itself. So, here a 0, here a 0, the whole thing reduces to 0. So, you are just left with this. Or in other words, a square b pi by 4a, or in other words, pi ab by 4. This is just this area. Multiply into 4, you will get the area of the whole ellipse. The last question, our curve was what? It was an ellipse, and we were dealing with the x-axis. Here we will deal with the parabola and the area enclosed by it with the y-axis. Let us first draw the parabola. Clearly its vertex is at the origin and it opens rightward because it is y square is equal to 4ax. If it was y square is equal to minus 4ax, it will open leftward. So this is how your parabola will look. Its equation is given by y square is equal to 4ax. And where is the y-axis? This is your y-axis. So we have got a curve. We have got a coordinate axis. But then what about this third line? Where does this y is equal to 2a comes? What if it does not even meet the parabola? Then what are we talking about? There is no area, right? So how can we be sure that it meets the parabola? It intersects with the parabola. And what is the point of intersection? Solve these two equations and that will give you the answer. Y square is equal to 4ax and y is equal to 2a. Put y is equal to 2a here. Then you will get x is equal to a. So, or in other words, your point of intersection, you get a point of intersection. And what is the point of intersection? It is a to a. So, this line does meet the parabola. And it meets it here. So, suppose this point is 2a. It meets it at a point a to a. So, that is good news. It does meet. So, what does that give us? That gives us an area. So this is the area that we have to find. There you have your curve, you have your y-axis, and there you have your axis. Then what do? Divide it into thin horizontal strips like this. So what do you have? One end of the strip is on the coordinate axis. Its other end, the breadth, its other end is on the curve. We have a curve. We have a coordinate axis, we have the y-axis, and we needed 2 points on the y-axis. You have only one. You're thinking you have only one, but what is the other one? Here, 0, 0. So you have what? You have a curve which is y square is equal to 4ax. Then you have the y-axis. Then you have 2 lines which look like this. Now, the answer will be 0 to 2ax dy. But what is x? The curve will give you the x. What is it? Y square by 4a. So that would be 0 to 2a. It is y square by 4a dy. That would be a y cube 0 to 2a. The lower limit, when you substitute, the whole thing becomes 0. So you will get 8a cube by 12a. That will become. So this will be your answer, 2a square. This much will be 2a square by 3. So now look at this question. How does our curve look like? This is our curve. Don't let the square root throw you off the track. You just have to square it and you will see y square is equal to x, or in other words it is a parabola which opens towards the right. Let us first draw the parabola. And what else does the question say? There are two lines. The first line is x is equal to 4. You see the area which is covered by the parabola and this line. You have this area and you have this area. You have this much area which is covered by the parabola and the line. But then what does the question say? There is a line x is equal to a which divides this area into half. That means from 0 to a, the area that you have, and then from a to 4, the area that you have, that is same. But what is the area from 0 to a? We know what it is, right? We have a, what do we have? We have a curve, we have an x-axis, and we have two ordinates. So what is it? 0 to a, y dx. Then what happens from a to 4? We have your curve, and there the x-axis, and two ordinates. Then what do you have? That is equal to a to 4. But then, did you notice one thing? We have taken only this side. From x-axis on to this side. What about this side? Just do into 2. Why is that? This is because you see the way the parabola is, it is symmetrical around its axis, which happens to be the x-axis. So it is symmetrical around it. So all you have to do is to get the whole area, just multiply what is on the top, just multiply it by 2. So there you have your equation. 2 and 2 gets cancelled. But what do you see here? Y dx. We cannot have that. We have to make it into a function of x. And where do we get that from? From this equation, which is square root of x. On integrating, what do you get? It is the cube root of 16. Now we move on to our second set of case studies. Now the first few questions we did, they were all of the same kind, right? How did all those questions look like? We had a curve, we had an x-axis or a y-axis. Here I am taking the x-axis, and we had 2 points A and B, and we found out how to find the area enclosed between the x-axis, the curve, and these two lines. And what did we find the equation to be? It was a to b y dx, where y was given by, the value of y was given by this curve. And now look at this situation here. What is happening here? You have a circle which looks like this. Its center is in the origin and its radius is 2. And then you have another line. X is equal to root 3y. So now, does this line intersect the circle? And if it intersects, where does it intersect? Let us find that out. Whenever you see an equation like this with x and y and no constant term, in the line no constant term, remember the origin lies on this point. It is not just this line. If you consider y square is equal to 4ax or y cube is equal to x, whenever you see an equation of any curve with no constant, remember origin will be a point on that. So similarly, on means on the figure, not inside the figure. So x is equal to root 3y. So what do we have? It passes through the origin. We know that for sure. But how does it cut? Like this, like this. Which way does it cut? For that, we have to solve these two equations. X square plus y square is equal to 4. And instead of x square, you can put 3y square. That means you will get 4y square is equal to 4. That means y square is equal to 1. Remember what I told you? There is always a plus and minus option. So you have two options. Y is equal to plus or minus 1. And depending on that, x will also have two values. it will be plus or minus root 3. Then why do we have so much options? Do you understand why? Because it is cutting it both at the first quadrant and the third quadrant. So both the 1 and the root 3 are the points where it meets it in the first quadrant, and minus 1 minus root 3 are the points where it is the point where the line meets the circle in the third quadrant. Now we are asked to find only the region which is enclosed by the first quadrant. But remember, if you have to find the area in the third quadrant also, remember to take, when you take a to b y dx, remember to take this as minus. We just don't consider it because we are always working in the first quadrant. So now you have the point of intersection. Now what do you see? You have a curve, but what sort of a curve is this? You see what is happening here? Here you have your x-axis, but what you see as a curve is what? It is actually a combination of two curves. Up to this point it is a line. From here onwards it is a circle. So at the point of intersection here will be what? Root 3, 0. This point we found to be root 3, and this point is the origin, right? So what do you have? From 0 to root 3, your y will actually depend on the line. And from root 3 to 0, your y will depend on what? The circle. So you see what is happening here? You see how this question is different from the other questions? In the other questions, we were only dealing with one curve. Here we are dealing with two curves. At the point of intersection, before that, y you will get from the line. So let us start solving that. How will our area look like? Our area should be what? Suppose this is O, and this is A, and this is B, and this is C, and this is D. So our area, what we want to find out is O, A, B, C, D. That is the whole area that we want to find out. But then we have split it into two. What is the first area? OAD. And what is the second area? DABC. So for the first area, you will integrate from 0 to the point of intersection. The second one, you will integrate it from root 3 to 2. For the first set, from 0 to root 3, what will give you your y? Your y is this, which is given by the line, which is x by root 3. But from root 3 to 2, what will give you your y? The circle will give you your y. And remember what I told you, there is a plus and a minus, but we are considering only the plus because we are dealing with the first quadrant. So there you have, add these two, you will get your answer. So this is what we get on integrating, and your answer is pi by 3 square units. Now we will do one more question the same way, where you will see a split. You will see a split and you will see your y, you will get two curves from which you have to get two y's. We will do one more question of the same kind. Again we will do a question of the same kind. So what are the two figures you have here? One is y square less than or equal to 4x. Don't worry about that. All it means is that it is the interior of the parabola, and this less than or equal to means it is the interior of the circle. The same thing if it is greater than or equal to, it will mean all the points in the exterior of the circle. Now this is the situation here. You have a circle with its center at the origin and its radius what? 3 by 2. And then you have a parabola which looks like this, opens rightward, and its equation is what? Y square is equal to 4x. Then it has to meet somewhere, right? What is the point of intersection? Solve these two equations. Instead of y square, put 4x. Then you get this equation. 4y square minus 16x plus 9 is equal to 0. 16 minus 16 you can write as plus 2 minus 18, right? So then you will get two values for x. But then if you substitute minus 9 by 2, you will see that this is no longer real. So this is the only value that we can use. Using this value, you will get 2 values for y. So you have 2 points. One is half and root 2. The other one is half and minus root 2. Why 2 points? Do you understand why 2 points? Because it intersects at 2 points. So one point here will be half root 2 and the other point here in the negative side of y will be half minus 2. So this is the point of intersection. So now coming to the question, what do you see? If you have to find the enclosed area, which is what? This. This is the area that we have been asked to find out. The area which is in the interior of the parabola and the interior of the circle, or in other words, this question, the one which we started our lesson with, we started this video with, this is our question. So how do we find it, and what have we done so far? We know how to find the area enclosed by the x-axis and a curve, but then what is the problem here? Here it is not two curves, it is actually the intersection of two curves. So what do? At the point of intersection we split. So what is the point of intersection? Here it will be 0, 0. What will be the point of, at the point of intersection you will get what? Half. 1/2 is where the intersection takes place. So from 0 to 1/2, what will give you your y? The parabola will give you your y. But then from half to 3/2, what will give you your y? The circle will give you your y. But then that is just this side, right? Which is bounded by the x-axis and this. What happens to the one below? Just do into 2, then you will get the answer. This is our final answer. From 0 to 1/2, what will give our y? Y will be given by the parabola. So, but you have to take the double of this because this is our entire area. So, this area and this area, take the double of this. From half to 3/2, again what do you have to do? You have to take the double, and then what is y given by? Y will be given by your circle. On integrating, you will get this answer. Now this brings us to the third and the last set of our questions. What do you have here? You have a parabola with x square and y plus y term. So it is 3x square is equal to 4y. So this parabola looks upward because it is plus y. If it was minus, it will look downward, and its vertex is what? It is at the origin. And then what do you have? You have a line which is 3x minus 2y plus 12 is equal to 0. Now you see there is a constant term. That means it is origin does not lie on this line. But then what can you find out? You can find out the x-intercept and the y-intercept. What are they? Those are the points where the line cuts the x-axis and the y-axis. How will you find that? First put y is equal to 0, then what will you get? 3x is equal to minus 12, or in other words, minus 40 is the place where the line cuts the x-axis, or in other words, the x-intercept is minus 4. Now, how do you find the place where it cuts the y-axis? Put x is equal to 0, then you will get y is equal to what? You will get y is equal to 6, or in other words, 6 is the place where the line cuts the y-axis. So you have got those 2 points, but that is not what we want, right? The points that we want are what? Where it cuts the parabola. You see these 2 points, you should get 2 points. Now solving these 2 equations, we get the point of intersection of the parabola and the line. We get an equation in x, which is what? X square minus 2x minus 8. Solving, we get 2 values for x, one positive and one negative. Why is that? The positive point is where it intersects the parabola in the first quadrant. But you see it also intersects it in the second quadrant, where x will be what? It will be a negative value. So therefore you get 2 values. So the first one here will be what? Minus 2 and 3, minus 2, 3, and this will be 4, 12. So there you have the points where the parabola and the line intersect. What do you have to find? the area included by the line and the parabola. That means what? This area. Now, cut this area into thin rectangular strips. What do you see here? Do you see how this question is different from the first two case studies that we did? What is different? Just refresh your memory and tell me what is different. You see here, the x-axis is here. The one end of the rectangle does not even touch the x-axis. So you see what is the problem we have here? In all the other questions, what did we have? We had a curve, we had the x-axis, and when we cut it into thin strips, we had one foot of the rectangle was on the x-axis or the y-axis. But you see what is different here? It is not even touching the x-axis. So what do? We ourselves will extend it. Then what will you get? You will get the area that this line makes with the x-axis. And then extend just this part. Then what will you get? You will get the area which the parabola makes with the x-axis. Right? Now subtract these two. You have had this area and then you found out what is this area. Subtract this area from this. See how neat it is. There you have your required region. Isn't it wonderful? Now let us start integrating. What is the required area? The area we have to integrate from x is equal to -2 to x is equal to 4. So these are our limits y dx. But then what is your y? Look what your y is. The upper part is given by this, the line. Which means where is the line? Here you have your line. From that you get x is equal to what? 3x plus 12 by 2 dx minus the area covered by the line minus the area covered by the parabola. The same limit, but then what is the y when it comes to the parabola? It is 3x square by 4 dx. Now all that is left is to integrate. Let us integrate and find out. Now this is the answer that you get after integration and applying the limits, and this is this whole chapter is about the application of integration. So that is why I am not going into detail about each and every step. We are just discussing how to apply the integration to find the area of the bounded regions. We will do one more question. Now what do we have here? We have an ellipse. Its major axis and its minor axis is all given. Next we have what? A line. A line in what form? A line in the intercept form. So we already know that this line cuts the x-axis at the point A. Its x-intercept is A. And what is its y-intercept? Its y-intercept is B. So it cuts the x-axis at the point A. It cuts the y-axis at the point B. So how will your line look like? Your line will look like this. So you see what has happened here. This question is quite easy. We did not have to find the point of intersection. It is given here. So now this line divides the ellipse into two parts. One is the bigger part, one is the smaller part. We need to find the smaller part. But then how do we do this? Any region you want to find the area, what do? Divide it into thin vertical strips. If it is with respect to x, then vertical strips. If it is with respect to y, then go for horizontal strips. But what do you see here? The same problem. We need to have 1 foot of the rectangle at one of the coordinate axes. But we do not have that. If we do not have that, what do? We ourselves will extend it. There you have. So now you can find the area enclosed by this curve and the x-axis and 2 points. Here x is equal to 0 and here x is equal to a. You can find that 0 to a y dx. What will give you the y? The y is this. We are dealing with our curve right now is this. It is the ellipse. So this equation will give you y. And what will that y be? Y square by b square will be what? 1 minus x square by a square. And finally you will get y is equal to b by a square root of a square minus x square. Remember, when we deal with y square, we will always get a plus or minus answer, but we are considering only the plus because we are dealing with the first quadrant. This y is what? And now, do you remember, this was the first question we did. What did we find out? The whole ellipse. The area of the whole ellipse was pi AB, and just quarter of it was pi AB by 4. So this actually is pi AB by 4. You can just refer to the first question. That is what we found out. But then this is the whole of the area covered by the ellipse. What about the area covered by the line? Divide this into thin vertical strips. See, now you have another rectangle with its base at the x-axis. So how do you find its the area covered by it? It is 0 to a y dx. This is also y dx, but this y is what? If we take this y1 is given by the ellipse, and if you take this as y2, the y2 is given by the what? By your line. So what is that? That is 0 to a. You see, the second y2 is given by the line, and from the line, if you get the value of y, you will find that it is b by a into a minus x. Now integrate it, apply the limits, and you will get this answer. So what have we got? We have got the whole of this area, the area that this part of the ellipse makes with the x-axis. We seen this line, what area it covers with the x-axis. Now subtract this one from this, then what do you get? You get exactly what you need. You get just this. You see what we have done? We have found out this whole area, then found out just this area, and then subtracted the two. And then what have you got? You have got your figure that you needed. So this one minus this one. So that means what? AB by pi by 4 minus half will give you the required area. Now what do you have here? You have a circle. Its center is at the origin. Its radius is a. Now you have a line x is equal to a by root 2. Any line, x is equal to 4, x is equal to minus 3 by 2, whatever, all of these lines are what? They will be parallel to the y-axis. That is fine, but where do we get this a by root 2? In which part? Here or here or here? Where exactly? Now a is a radius, that means a is positive, so a by root 2 is positive, so it must be located somewhere here. Now 2 is what? It is greater than root 2. Take the inverse, your inequality gets reversed. Now multiply throughout by a positive number, the inequality is retained, it does not change. So what do you have? If you take the half of a, if you take this length and take its half, a by root 2 is even greater than that. So it comes somewhere here. Now you see the area. This is the area that we are talking about. This is the smaller area, and what do? We divide it into thin vertical strips. So good news, what is that? No complications at all. 1 foot is in the x-axis. Good news. What about the other foot of the rectangle? It is on just one curve. We are not dealing with any intersection of two curves or all, just very plain, just one curve. So this is good news. So what are we going to integrate it from? This will be a by root 2 and this will be a. So you will be integrating it from a by root 2 to a, and this y dx. But then remember, this is just above the x-axis. But then what about this part? Do into 2. That's all. So what will give you this y? It is square root of a square minus x square. Remember, there is negative and positive. I am taking only the positive because we are dealing with the positive with the first quadrant. So this is your answer. You integrate it and your final answer. Again, I am not going into the each step of the integration because this is just to show you the applications of integration. So this will be your answer. So what is the curve we have here? It is a line, which is given by the equation y is equal to 3x plus 2. To draw the line, find the x-intercept and the y-intercept. Where does the line cut the x-axis? For that, put y is equal to 0. Then you will see x is equal to minus 2 by 3. So the line cuts the x-axis at the point minus 2 by 3. Now to find the y-intercept, the place where the line cuts the y-axis. For that, put x is equal to 0. Then you will get y is equal to 2. So its y-intercept is here. It cuts the y-axis at a point 2. Now join these 2 points. You will have your line. There you have your line. And what are your ordinates? One ordinate is minus 1 and the other ordinate is plus 1. So we have to integrate it from minus 1 to 1. So let us start drawing the lines, the ordinates. So we have to find the area bounded by the line and these 2 ordinates. So now this is the whole area that we want. But did you see how the y is? Do you see how our curve goes? One half of the curve is above the x-axis. The another half is below the x-axis. If you see at this place at minus 2 by 3, you can see the curve is above the x-axis, which means your y will be positive. It falls in this area, so your y will be positive. But the second one falls here, which means the y at that place will be negative. So usually what do we take? We take it as a to b y dx, right? But here you have 2 of y's. One goes from minus 1 to minus 2 by 3. There you will take the minus of the y. If y is this, the minus of the y would be this much. And then to that what will you add? From minus 2 by 3. From this point to this point you have negative y. Then from here to 1 you have positive y. There. Integrating this, you will get the answer. And as with the other questions, I am not going into the integration because this is just for the application of integration. So once you integrate it, you will get the answer, which happens to be 13 by 3. With this, we come to the end of our class. Let us see a quick recap of what we studied so far. We started with just one curve. We found the area bounded by that curve, the x-axis, and 2 points on the x-axis, 2 ordinates given by the equation x is equal to a and x is equal to b. This is the region, and the area of this region is given by this formula. Now, how did we get to this answer? We divided this region into thin vertical rectangular strips like this, such that 1 foot of that rectangle was on the x-axis and the other foot was on the curve. And this y is given by the equation of the curve, whatever your curve is, a circle, a parabola, whatever, you will get the y from this, the curve. From that we moved on to 2 different curves. Now look at this case. If we have to find the area bounded by the parabola and the circle, all we have to do is find the area above the x-axis and multiply it by 2, because this is a symmetrical figure. So how did we find the area above the x-axis? We can again divide it into thin rectangular strips. But then there is a problem. So if this is A and this is B, you see the point of intersection? We found that if we draw a rectangular strip in this region, its one foot is on the x-axis, good news, but the other foot is on the parabola. But then if we draw a rectangular strip after the point of intersection, what did we see? Its one foot is on the x-axis, good, but its other foot is on the circle. So what did we do? We divided the integral into two parts. From a to c, we have y1 dx, and from c to a, we have y2 dx. What is y1? y1 is given by the equation of the parabola. What is y2? y2 will be given by the equation of the circle. We split the integral. Two different limits, two different equations for y. This brings us to the third case. What is the third case? We have to find the area which is bounded by the line and the ellipse. And what did we say? As usual, we have to divide the required area into thin vertical strips. Then what did we see? One end of the rectangle was on one curve, the other end was on the other curve. This does not match our original model. We have to get 1 foot on one of the axes. So what did we do? We ourselves extended it like this. Suppose this is say minus a and suppose this is 0. Then by integrating the ellipse, I will take this as y1. So we can integrate the ellipse from minus a to 0. That will give you what? That will give you the area of this entire region. Then what did we do? Consider the rest. Consider this portion. Consider the area which is enclosed by the line and the x-axis and the 2 points on the x-axis. Then its area is given by y2, where y2 is what? It is the equation of your line. So now what is the required area? The required area is this. If you subtract these two, you will get the required area. So these are the three different kinds that we studied today. With that, we come to the end of this class. Till I meet you next time, you take care. Assalamu alaikum.